So we're going to be using the properties first, and then we'll move into using the change of base formula. Will be the last thing that we do. So the first ones say to expand the expression. So that means that we're working this direction. So we're moving left to right here. So if we have like log base b of m times n, we're going to be rewriting that as log base b of m plus log base b of n. So that's expanding. When we get to condensing, it'll be working right to left. So number 16, we got the ln of 15x. So those two things are being multiplied by each other. So the log of a product is equal to the sum of the logs. So I rewrite this as the ln of 15 plus the ln of x. And at the moment, you're probably like, why do I need to rewrite this? Like, what is this going to be useful for? It will be helpful in the next section where we're actually solving logarithmic equations, that when you can separate things, it'll make it easier to solve. Because the ln of 15 is just a number, okay? But the ln of x, well, we don't know what x is, so that's not going to do anything for us. But that's all you have to do on the expanding ones. 18. Log base 5 of x to the 5th. So this one, we have a power. When we have a power, we throw it out front. So this just becomes log base 5 times log base 5 of x. 20. ln of 12 over 5. So this one is the log of a quotient is equal to the difference of logs. It's always top minus bottom. So this is the ln of 12 minus the ln of 5. So notice when I'm expanding, I go from having log written one time, well, aside from number 18, because that's a different problem, but to the log written multiple times, okay? When I'm condensing, I go from log written multiple times to it will be written one time in my final answer, okay? That tends to be where people get confused. 22. ln of 4x squared y. So in this case, I have three things that are being multiplied by each other. So this is going to become the ln of 4 plus the ln of x squared plus the ln of y. I'm still not done because x is being squared. That means I need to do another line of putting it out front. Now, as you get more comfortable, if you can see that and go ahead and put it out front from the beginning, that's also fine. But just know that it only goes on whatever term it's touching. So that 2 is only going to be going in front of ln of x, not in front of the other ones because only x is being squared. So that's why a lot of times I will wait and do it after I've already split it. So my answer will be ln of 4 plus 2 ln of x plus the ln of y. So this would be fully expanded. (28) ln of 6x squared divided by y to the 4th.
Oh, I know how to do this one.
Okay, then tell me how to do it.
It's going to equal 2 ln x. I mean 2 ln. No.
2 ln 6x minus.
No, because only the x is
Why
squared.
don't we do it in like several steps?
No, but that's
Yeah,
not fun.
So if you have stuff on top that's being added, and stuff on the bottom. Okay, well, hold on. Let me rephrase. If you have stuff on top that's being multiplied, we're going to be adding those things, and then we're going to be subtracting off the log of the bottom. I would do this one in steps because there's so much happening. So I would have the ln of 6 plus the ln of x squared. Then this is on the bottom, so minus the ln of y to the 4th. Now I can do what you were trying to do and put the stuff out front because it only goes out front of what it's directly touching. So that ln of 6 is not going to have anything in front of it. So that one just comes down. Plus 2 ln of x minus 4 ln of y.
Any question?
Yes.
No.
Yeah, oh, that's my knee that I scraped.
In tennis.
Tennis injuries.
Is your arm okay from this surgery?
Yeah. I just banged it on the fence.
Does it actually feel better, or are you just saying it's better?
I'm saying it's better.
You played basketball.
I did, that's why I'm saying it's better. It only hurts when I you bang it. That's when I'm not banging. But you can bend it.
I'm going to do a modification of the previous problem to show you something different. So the ln of 6 over x, I'm just going to do xy. I'm not going to do the thing where I'm throwing it out front. If I have this situation, there's two different ways that we'll be able to write this answer, which is the main reason I want to point this out to you. So this would first of all be the ln of 6, then minus, these things are on the bottom. I can do this in parentheses as the ln of x plus the ln of y. So this is minus parentheses ln of x plus ln of y because those things were being multiplied by each other. Okay, but they're on the bottom, so I've got to subtract them off. The other way that I can write this is I can say the ln of 6 minus the ln of x minus the ln of y. It's the same thing, just written a different way. I typically end up writing it the way that's on the bottom. I don't think, well, there's one problem it looks like that I'm seeing immediately at a quick glance that will require you to do this. The book appears to write it the bottom way, which is the way that I typically write it. But I'm just letting you know for a couple reasons. One, when we go to condensing, they could write it either way, and so it would turn back into this. But I just want you to see that. Obviously, if they were raised to a power, we would put the power out front still. But I just wanted you to see that. 30. Log base 3 of the square root of 9x. So, I've got a couple things going on here. What do we notice?
The root can be rewritten as power to the half.
Okay, so if I do that, then I would have log base 3 of 9x raised to the 1/2. That means that both of those things are being raised to that. So, then what?
You move the 1/2 out.
Yep.
The log.
So it'll be 1/2 log base 3 of 9x. And then what would I have to do?
You can change the 3. Wait, can you take 3 out of the 9x? How am I don't know how to explain it, but
I know what you're trying to say, and normally I would say that I would do that. The book doesn't. I'm not really sure why they don't. But what they're doing is they're just splitting this. So they end up with 1/2, or well, 1/2, and then log base 3 of 9 plus 1/2 log base 3 of x. Yes, technically this would be log base 3 of 3 squared, which is equal to 2, but they don't write it that way. I think just because they want it expanded, they're not rewriting it. Now, this is fine. The other thing that you will see, or the way that they will write it, and what we could have done a little bit different instead of writing it in this way first, is 1/2 times log base 3 of 9 plus log base 3 of x. So they've factored out the 1/2. I would take it either way here. So either way that you would leave that would be totally fine. Now, on the quiz or the test, if you rewrote this log base 3 of 9 as log base 3 of 3 squared, and then you said that that was equal to 2 times 1/2, which is equal to 1, that's also fine. But for the purpose of the book, they're just expanding because technically speaking up here, in most situations, what I would do if I wasn't just specifically expanding is I would have rewritten this as log base 3 of 3 root x because the square root of 9 is 3. And then I would have never had to go down here and do it that way. Again, I'm not really sure why the book doesn't do that, but they leave the answer as 9. I think it's just because they just want you to expand it and not do anything else. But if you went that route, I also would take that. So, anyways, there's that. All right, any questions about expanding?
No.
All right, so then we're going to get into condensing then. All right, so 34,
Those used to be my shoes.
the ln of 12 minus the ln of 4.
Like condensed milk.
So we're writing this as one single log. My final answer will only have ln written one time. That is the most common mistake. People like to then, when they see this minus, don't write this. People take this and write ln of 12 over the ln of 4. That is wrong.
That's what I'm saying.
That would be
Okay.
pretty-
It is 1 log ln of 12 divided by 4.
Oh.
So it gets written one time. When we're condensing, we only want it one time. When we're expanding, we want it multiple times. Condensing, we want it once. Now,
Simplify.
absolutely. So this should become the ln of 3. Obviously, once you've simplified it, you can't really get it back to the original, right, in this case. But anytime we're doing this, especially when it's one that has more pieces to it, we can always re-expand it and get it back to the original to make sure that we did it right. 38. 5 log base 4 of 2 plus 7 log base 4 of x plus 4 log base 4 of y. So anytime I have one that has things in front, when I am condensing it, I would raise the stuff to the power first that's in front, then I would go through and combine it the rest of the way. So I would take these and put all of the powers up here where they're supposed to be. So log base 4 of 2 to the 5th. If you want to go ahead and write that as 32, you can. It's up to you. Plus log base 4 of x to the 7th. Plus log base 4 of y to the 4th. Now these things are being added, so I multiply them. So this is going to become log base 4 written one time. I'm going to go ahead and rewrite 2 to the 5th as 32. So if 32, x to the 7, y to the 4. And that would be fully condensed.
Wow.
What in the world?
Stretch it. Wow.
Is that good?
Let's see.
Where's LeBron?
42. 2 times, and this is like a parentheses, log base 3 of 20 minus log base 3 of 4, and then outside of that, plus 0.5 log base 3 of 4. Now, it probably goes without saying, but anytime we are condensing or expanding, well, not so much expanding, but condensing, the things have to have the same base on the log. Obviously, all of these ones do, but just saying, if you ever had multiple bases for some reason, you can't do them unless they're all the same. So it's just like terms. Anyways. So when I have one like this, the first thing I would do is what's in parentheses before I throw this 2 up top, because it will make it easier. So this is 2 times log base 3 of 20 over 4, and then plus 0.5 log base 3 of 4, which I actually, well, I'll do it in this step. Now, 20 over 4 is what? 5, so I'm going to rewrite that as 5. Now I'll put this 2 up top, so this becomes log base 3 of 5 squared, which obviously we know what that is. And then plus log base 3 of 4 to the 1/2. So this is really log base 3 of 25 plus log base 3 of what? 2. Yep. So remember, if it's raised to the 1/2, it's the square root. So now these things are being added, so I can multiply them. So this becomes log base 3 of 25 times 2. I would normally just go straight to writing that as 50, but in case you go back to look, I'm writing it this way. So log base 3 of 50 would be the final answer. Now, obviously, you could type this in your calculator and figure out what log base 3 of 50 is. That's not what they're asking us to do. They just want it condensed into a single log. Okay? Any questions on that stuff?
No.
All right, the last thing in this section is the change of base formula. It just says use the change of base formula to evaluate the logarithm. Now, there are different ways that I can write a change of base. I can use any base that I want to write them. I will typically use the common log, which is log base 10, or the natural log, which is log base e, to do it because those are buttons on my calculator I can quickly hit. If you want to change them to log base 274, you are welcome to do that. It's just going to be more work on yourself. Okay? So, change of base, I've got number 46, log base 5 of 13. Now, you can obviously, as we have said, type that into your calculator as just log base 5 of 13 and you can give me a decimal number. That's not using the change of base formula. You have to show the change of base to get full credit. So if I want to use a common log, I would do log of 13 over log of 5. So it's always the log of whatever this number is over the log of the base. Okay? Or whatever log that you decide to use in your change of base. At this point, you would type in to your calculator log 13 divided by log 5 and you get a number. Somebody can do that. I'm also going to show you that no matter what we use, you get the same answer. So somebody else type in the ln of 13 over the ln of 5 and tell me what you get. And we're going to go to, the book goes to 3 decimal places, so we'll just go to 3 for right now.
I left my calculator in my car.
You're going to need to make sure you have it tomorrow.
1.6.
3 decimal places, buddy.
Oh, she cut you, buddy.
That caught me off.
1.594.
Look up what's 13 divided by 5.
Okay.
It's not going to be that.
Who did the ln one?
Huh? Wait, why would the logs fit?
Yeah, what is log?
It's
Like I know
The inverse of e.
but what is it?
the inverse of e. She just said that.
But what's
A number.
The
2.71.
outverse.
Did somebody do the ln of 13 over 5?
yeah,
I
yes,
don't know if
it's
it's
right.
It's the same.
Or the
exact
ln
thing.
of 13 over the ln of 5?
It's the same exact thing.
Yeah. Yes, it should be the exact same thing. Thank you,
Why
Mason.
why wouldn't the logs cancel each other out? Like on the, why wouldn't they cancel each other out?
What do I relate it to?
It's the function.
Alright.
Yes, it is technically a function. So it's, I'm trying to think of why I can do this. So why does, let me see how else I can put this. Why does the square root of x and the square root of 4 not become x over 4? Why do the square roots not cancel each other?
I thought they did. Oh, because it's all one square root. It'd be square root of x over 4. Wait, that's not right.
Well, yes, okay, but it's like a function like within.
Like that could go in front too.
It's like, let me hold on. I have a better one. Okay, why is the cosine of 5 over the cosine of 4 not 5 over 4?
Because the cosine of 5 isn't 5.
Well,
Okay.
cosine is
That
a
makes
number.
sense. I got
So
it.
the log of 13 isn't 13.
Okay.
Because the cosine is a
Probably
Just like log of
thoroughly
13
confusing
isn't log
Julia
times
right now
13.
if she, not when she goes back to watch it, I'm saying.
No, whenever I go back to grab your leg.
You'd be like,
it's
why are there
5.
trig functions in here?
Like it's different every time.
All right,
Yeah, like
one more.
sometimes it's here, sometimes it's there.
Now, I will also
Like
tell
that.
you, I'm not going to make you do this, but this was like log base 5 of 13, which also, if you want to check to make sure you did the change of base formula right, you could also, in your calculator, then plug in log base 5 of 13 to check it. But you could also, let's say I wanted this as log base 4. I could do this as log base 4 of 13 over log base 4 of 5, and I'm still going to get 1.594.
What?
Okay, you can pick any base that you want, and you will get the same answer.
275.
These are all equal to the log base 5 of 13. I will use one of them in blue. I will not use the green one. Way more work.
I like the one in green.
Well, you can do that one. That's fine. It's more work
Makes me
though.
happy.
Oh. I know
Let's
why.
see.
'Cause they're the same.
56. The log base 8 of 32.
There's some big. Never mind, I'm not gonna ask that question.
So again, I usually just use common log, so this would just be log of 32 over log of 8. If you, again, I said this yesterday, but all of you have the newer calculators, or at least like something equivalent to what I have. If you ever borrow someone's who's older and you want to type in a log base of something, a lot of calculators don't have that, and it only has this.
1.667. What?
All right. Any questions on that?
Happy Hanukkah.
Can I get one? Happy McDee's.
Yes. All right. Problems.
I didn't eat breakfast this morning.
Oh, I forgot about the biscuits. Yes, when I get back.
All right. It's 15 through 41, every other odd.
Oh, I was about to say.
Okay, just as a refresher, that means 15, skip 17, 19, skip 21, 23, so on and so forth. And then 49 and 55 for change base problems.
I was gonna say I cannot have another 0 in for homework, so I would not be doing all that.
Wait, what section is this? 7.
7-5. Page 510.